Hello guys. Here we have a fresh topic on Mat251. This topic is actually based on reduction formula. That is the first thing you need to take note under this course. Um, to generate a reduction formula for integral of sine nx dx, we need to follow these steps. At first, we let in integral of n degree for sine x equals, let in be equals to sine nx dx. Then after we let this in to be equals to sine of nx dx, then the next thing for us to do is to manipulate. But at first, I would like to introduce to something. Having this sine nx, I can rewrite this thing as sine of x all raised to the power of n, right? And at the same time, I can rewrite this expression as sine of x n minus 1 times sine of x. This is the idea of indices. There's an invisible power here, which is 1. So by the time you multiply this together, you end up having sine x is power of n back. That is, you add the powers together, then you have this. So trivially, we can decide to say that in is equals to integral. This sine nx is this. That is, can be written as sine n minus 1 of x, which is still the same thing, then times sine of x, then dx. So the whole of this sine nx dx gives us this sine n minus 1 of x, then times sine x dx. Now if you multiply this and this together, you end up having sine nx back. So I've not done anything wrong with the expression. So considering this that we have here, I can decide to write it very well by writing sine of n minus 1 of x dot sine x, then dx. So you can see it clearly. So what do you need to do from here? The first step, I repeat, the first step is to simplify this sine nx by using this pattern. And then the second step is you need to impose what we call integration by parts. So here in this case, by using integration by parts, we can decide to say that in is equals to, by formula integration by parts, in equals to uv minus integral of v then du, such that we let u to be equals to sine n minus 1x, and then we let v equals sine x dx. I hope you get this clearly. Now when you get to this extent, I think you should be able to solve this and break it down. Then when you get here, we believe that du equals, I can decide to use the trigonometric rule here, trigonometric function of differentiation, and then I will have to take this n minus 1 down times differentiate this sine x. When I differentiate sine x, I will have what? Cos x. And at the same time, times, repeat everything back, this sine n minus 1 of x, but on one condition, you have to subtract 1 to the power. So that's the pattern for it. Hence du gives n minus 1 then cos x times sine of n minus 2 of x. So this is how it works. So I've gotten whatever my du is. So I'll just come here and substitute it. So I need v also. Hence v equals, v equals sine x dx, right, from here. Then uv minus integral of v du. So we make u to be equals to this and dv to be equals to sine x dx. Sorry for that.